Hey chemistry students, this tutorial is going to focus solely on single replacement reactions. In the below four equations, we're going to predict the products. If the reaction can occur, we will simply write NR for no reaction. And as we go through these problems, we're going to use our activities series. So I'm going to set that to the side. All right, that works. All right, number one, we have nickel plus sodium nitrate. So first and foremost, there are two types of single replacement reactions, where your first element out front is a metal or the element is a halogen. So we first need to identify what type do we have, and nickel is a metal. So in this type of single replacement reaction, we're going to see if nickel will replace sodium, which is the metal in our ionic compound. And to do that, we're going to look at our activities series. The only way that nickel can replace sodium and form a compound with the sulfate group is only if nickel is more reactive or active than sodium. So we're going to locate both nickel and sodium up top. All right, so sodium is actually most active. So the higher up on this particular list, the more active. So sodium is more active than nickel. What this means is that nickel is not active enough to take this sulfate group away and to form a compound with it. So this reaction will not occur. So we are going to write NR for no reaction. Right? Number two, we have fluorine reacting with barium chloride. So fluorine is a halogen. So in this type of single replacement reaction, we're going to see if fluorine is active enough to replace the other halogen in this ionic compound, which is chlorine. To do that, we're still going to use our activity series. We have the halogens down here. So the only way that fluorine could bond with barium and kick out chlorine or replace it is if it's more active. And fluorine happens to be more active than chlorine. So in this scenario, chlorine will be replaced. Now I'm going to write Cl2 to satisfy what we call Brinkelhoff. And the new compound form will be barium fluoride. So use your knowledge of ionic compounds. So barium fluoride is BaF2. All right, let's move on to number three. And if you notice, number two is actually already balanced, so no need. Number three, lithium plus calcium phosphate. All right, so we're going to see if lithium, which is a metal, can replace calcium. So we're going to locate both of these on our activity series. So we have lithium up top and then calcium below. So lithium is more active than our calcium. So calcium will be replaced. So we're going to write calcium. Just write its chemical symbol only if it's in what we call Brinkelhoff. Do you write a little subscript of 2? Now we're going to have a compound form between lithium and phosphate. So you're going to have to use your knowledge of their charges when they form ions. So our compound will look like Li3 PO4. So this is lithium phosphate. You would then want to go and balance this equation. So let's go ahead and do that quickly. Put a 3 here to make my calciums the same. I need to have 2 of this whole phosphate group, so I'm just going to stick a 2 out front. All right, now I'm going to need 6 lithiums. Ta-da, and a coefficient of 1 out front, an unspoken 1. All right, number 4. Bromine reacts with potassium chloride. All right, so bromine is a halogen. So we are going to see if bromine is active enough to replace this chlorine. So let's use our activity series, locate bromine. This is the atom that's going to try and replace. And then chlorine. Right, and bromine is actually lower, it's not as active as chlorine, so this reaction will not happen. So simply write NR for no reaction. All right, thank you for stopping by. Continue to practice with your practice packet, the starters and finishers online, and as always, ask me questions.